6.3, we're going to talk about fuel and then some random things about the use of fuel. The first fuel that I want to talk about is wood. So it's most commonly in forms of firewood. It could also be like wood pellets, wood chips, wood logs, charcoal. We see that it's most often used in developing countries because it is easily accessible. And this also is going to tie in the next unit we talk about. I believe it's the next unit. We talk about air pollution. Because it's so easily accessible, this is, what they use to burn in order to heat their homes and cook their food. But then, as a result, you have a lot of pollutants and things like carbon monoxide and particulate matter in the homes, and it leads to a lot of respiratory issues that we see in homes that have to do that. But that'll come next unit, or the unit after that, one of those two. Next one is peat. Peat is partially decomposed organic material that can be burned for fuel. If peat is exposed to a lot of heat and pressure, it'll turn into coal. And this is over many, 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 many years. So we break coal down into three main types: lignite, bituminous coal, and anthracite. And sometimes you'll see a differentiation between subbituminous coal and bituminous coal, so it's just not quite there yet. They're broken up into these categories based on the carbon content that they have, and that's determined by the heat and pressure that they're exposed to, as well as the depth of burial. The depth of burial matters because you need to have anaerobic conditions to turn these old plants, old animals, into a fuel. So you see, as this substance gets exposed to more heat, more pressure, more time, that's how we get coal like anthracite. So anthracite is the most desirable because of a very high heat content, low sulfur content. The sulfur is important, as we'll see in the air pollution unit. When sulfur dioxide is released into the air, chemical reactions will happen and it'll turn into sulfuric acid, and that's what we call acid rain. So we like to see less sulfur dioxide because that means our factories don't have to take out as much sulfur dioxide before going into the atmosphere. But it is harder to find. We see bituminous coal used a lot. And again, it has a higher sulfur content. The big thing you want to know from this is that more time, more heat, you get more carbon content and less moisture. It's kind of like squeezing out a sponge. So the less moisture present, the more coal you have, or the more carbon you have in your coal. Next fuel is natural gas. Natural gas is mostly methane. It is considered the cleanest burning of our fossil fuels, since it emits just like 50% less carbon dioxide than coal. But again, it is still a fossil fuel, so it still does release carbon dioxide. So it's not ideal, but that's why we've seen a transition to using more natural gas, and that's why there's been this big rise in fracking, because natural gas is considered cleaner. Okay, this is kind of transitioning to like the random uses. I want to talk about tar sands. So tar sands, we have these deposits of, it's not really crude oil, but it's kind of like it. It can be purified and processed to become crude oil. So it's called bitumen, and so it's like this really sticky tar stuff. It's also got clay and sand and water and all this stuff. So what we can do is we can inject steam down into these deposits and then loosen it up. And that way we can suck it up and then process it and take it through pipelines to, whatever place will refine it and take it into the crude oil that it is. You want to know about Alberta. So Alberta, because they have such an enormous reserve of tar sands, they are the third largest proven oil reserve in the world. So this is a really important part of the Canadian economy. And they do have regulations there that say, like, once you're done mining this area, you have to reclaim the land afterwards. Being said, not many places have been reclaimed. You do need to deforest huge areas of boreal forest, and that goes into a whole other issue. We've talked about deforestation before. It leads to habitat loss, which is leads to loss of biodiversity. It leads to things like erosion. It leads to increased climate change because we've lost a carbon sink. So all sorts of issues. We also have issues with the waste produced from this mining. So they'll make toxic waste ponds, and then that can leak into groundwater if they're not properly lined. They produce air pollution. They're destructive to indigenous communities that rely on those forests for their hunting and for their way of life. And it's, they should be considered in these decisions about where to mine, but unfortunately, that's not always the case. This is an example of a tar sand operation. So if you look off to this corner here, that's what it used to look like, all of this region, but it was deforested and then extensively strip mined to get to these areas where they can get the bitumen out. Along with this, you'll want to know about the Keystone XL pipeline. The Keystone XL pipeline is a proposed pipeline that would go, so this green pipeline already exists, and the red dashed one would allow like a more direct route. It would also increase the volume and the carrying capacity. An extension would also take it down to the Gulf of Mexico where there are refineries, and then also they can send it out to other countries and other areas. However, bitumen's more corrosive, and so there's more of a risk of leaks of those pipes, and you have to think about the areas that those pipelines are then going over, the damage that it would do if they were to have a leak. And I'd have to do my research again, but I know there was a pretty significant leak not that many years ago. I can't remember. So it is a real problem and a real risk. So it goes over sensitive ecosystems like the Sandhills ecosystems in Nebraska. It goes over the Ogallala Aquifer, which is contains water that this entire region depends on for their fresh water, for their irrigation. And so it's a really big decision. Under the previous administration, it had been shut down. Under this administration, it was approved, but it hasn't been built yet because it's been going back and forth, a lot of legal things. So that's something that's still in the news. You probably have seen it before, but just want to provide more background. That is an important case study to note for the AP exam. A fractional distillation is how we take crude oil and turn it into all the different things that we use it for. So crude oil is just a conglomeration of a bunch of stuff, a lot of different molecules of different sizes, and we can separate those different molecules based on their boiling point. The larger molecules require a lot of energy to get them to boil, and so with the more energy, more heat, we can separate out those things. There are other things, the smaller molecules, they have a very low boiling point. We can get those out pretty quickly. That's how we can take one thing and turn it into the stuff that we use for roads and things for ships and cars and planes and our chemicals and fuel. And, our gas for propane grills or something like that. So that's pretty important to know. Last thing I want to talk about is cogeneration. So cogeneration is when you take excess heat that comes from the combustion of fuel. And then usually that heat we have to release out into the environment. But it's a way of capturing that heat that results from the burning of this fuel and then either reusing it or we can use it to heat homes as opposed to having to create that heat from electricity. So that's all.